Okay. So yeah, let's get started. Shall I read the questions? Do you want to start in any particular order? Do you want me to go through what I have prepared as a diagram? Like, how do you want to do this?
Yeah, maybe we can start with the architecture summary
Okay.
that you made.
So it's a quick diagram of the components as I see them. I kind of see like the things that exist in the cloud that people might operate or we might operate, but just generally away from the devices and away from the build system. Things that exist on the devices, here I call them device services, and things that exist during the build process, and this is just the build system. So
Mm-hmm.
most of this are existing technologies. There's very few new things that we add to this mix. We're just trying to combine them in useful and interesting ways. Um, so starting in no particular order, like looking at the build system, we use Yocto, which is a ginormous project that has build recipes for a lot of different software. Some of them are in Yocto directly. Some of them are well, it's the terminology naming there is kind of confusing. There's like Yocto, there's OE Core, there's BitBake,
Mm-hmm.
which is like the build system itself. They're all kind of intertwined, but there's a ecosystem where people create those layers that describe how to build something, how to build a specific piece of software. That is extremely configurable. It's really flexible, and instead of giving you one prescribed way to use something, it exposes a lot of knobs where the entire build process can be tweaked and tuned to specific requirements. Like for instance, you can build the entire operating system with a different libc across all
Mm-hmm.
these packages. You will build them with a specific libc, and it has a lot of flexibility in how you can combine all these things, like combine all these layers that bring in individual pieces and adjust what other layers do. So for instance, Uniro has a number of layers that adjust what is in other layers, like adjust something from Meta Raspberry Pi, adjust something from OE Core itself, adjust something from Meta Intel. So they have, it's very flexible, sometimes kind of difficult to figure out exactly what is going on, but the point is, it's a tool that at build time exposes a lot of options for someone to create kind of exactly what they need. And if they don't have a knob that does exactly what they need, there's a way to like provide that knob either by contributing this knob upstream, so in a specific source repository that contains like for instance the specific meta layer that contains the packaging for a piece of software, or even in a completely different place, like we do a lot in Oniro, where we tweak and tune existing layers and their recipes so that they work well with our vision of how this system should look like. So that's Yocto. That's like the umbrella project for the whole embedded stack. BitBake is a build tool that Yocto is using.
Mm-hmm.
Technically, BitBake is a standalone repository. It's a separate project, but Yocto uses BitBake. And when you take Yocto, you have a version of BitBake, you have a version of OE Core, and it's all combined into one consumable package. And if you have been trying the build instructions, you have been
Mm-hmm.
using BitBake, you have initialized
Feedback.
it,
Mm-hmm.
and it's part of one set of repositories that we create that we obtain when we create a workspace where people can build things. There's West, which I've used pretty much not at all, which is kind of like BitBake but for Zephyr. For
Mm-hmm.
reasons, it's like not maybe not precisely, but I'm sure people will correct me on that. But it's the tool you use to interact with the build system when you work on Zephyr projects. And Yocto is mostly Linux-based projects. And
Mm-hmm.
sitting in the same group but being kind of different is Hogbit CTL, which is a new piece of technology that we created just recently, which is sitting at the edge between the build system and the cloud. So it's a convenient command line interface to configure Hogbit, which is running somewhere else, and feed it with pieces coming from the build system, feed it from
Mm-hmm.
with kind of different types of build artifacts. So a lot of the documentation that Oniro has describes the build system. So it describes how you get started to have a workspace, how you set it up, how the pieces interact. So there's a lot of focus on that. And there's a little bit less focus on the other parts because they have been a little bit less developed, and we have mostly adopted things. So we are not like writing a lot of new documents from scratch there. So let's look at the cloud services. So
Mm-hmm.
in the cloud, we have right now mostly Hogbit. We're trying to provide a very good experience if you are using a device that will be managed through Hogbit. And Hogbit is a part fleet management solution and part like a update server. It's something that you would operate where you have direct control over a potentially a large number of devices. So, as an example, maybe like a cable modem from a telco that is at your home, that is technically in your home. It's plugged to your wall, but technically the telco is managing it. They can reconfigure it remotely. They can
Mm-hmm.
update it remotely. It's this sort of interaction. Another example might be a city that operates a large number of pieces of the infrastructure, and they effectively have a central way to observe them, to manage them, to control them. Maybe not only through Hogbit, maybe it will be a multiple, like a stack comprised of multiple pieces, but Hogbit would be a piece that would effectively own all of these devices and tell
Mm-hmm.
them what to do at some level. So, in contrast, let's say that you are a manufacturer of smart appliances for a house, and you have a bunch of like a smart washing machine, smart lights, smart vacuum cleaner, but you don't technically manage them in people's homes. There would be something maybe like a gateway or some kind of bridge that
Interface.
would be interfacing with them, and technically the owner of these devices would have an app or would use a browser to tell those things to do things like maybe there's an update, so there would be a prompt, but typically the devices are not going to update automatically. Typically there will be some kind of user interaction, or even if there's some kind of automatic update, it's not to this extent that you can see in Hogbit that you can tell individual devices to do individual operations. Here it's like
Mm-hmm.
you're mass pushing software, and some devices are online, they will get it. Some devices will just notice it and ask for the confirmation from the user. So it's like you're not entirely in control. And when we leave this part where you're entirely in control and leave Hogbit, this is where NetOTA kind of comes into the picture. So NetOTA is a piece, it's like a simple service that runs in the cloud that you can point a device to, and the device will discover that there's an update. And based on some other conditions, it can choose to automatically update, or can choose to prompt the user, or can choose to, just acknowledge it and wait for some kind of operation. But the interaction is one way, so it will never actually ask for commands from NetOTA. It will just wait. It will just discover there's some opportunities for it to do things.
So like the server pushes directly to the devices.
No, actually, no. In both cases, for Hogbit and NetOTA, the devices will poll the server. They will not
Mm-hmm.
connect and maintain like a connection. They will periodically just check.
Mm-hmm.
But the difference is that when you check what to do with Hogbit, Hogbit tells you, hey, I have precise instructions for your device, and you have just going to do this, and the device will just obey. In NetOTA, it's more of like an offer. I have these software pieces available, and do whatever you like with them. Maybe you want to update. Maybe you want to, um, unlike in Hogbit, where Hogbit tells you precisely which piece of software to install. In NetOTA, there's a number of different choices, and the devices have
Ah.
preferences, and based on these preferences, they can actually follow something. So, for instance, you can have like a major update, but you can still maintain the old version. So you can have actually two things available at the same time, and devices may
Ah.
choose to follow the new one or the old one based on the preferences of the owner. But from NetOTA points of view, is just giving it with the options, and if you want, it also provides you a way to download the software, but it's just like it's a different model. It's more like a Windows update or like a classical Windows distribution where there's some kind of archive that has some kind of packages, and you can update or install based on what you want. And Hogbit is.
Those
Mhm.
sorry.
Go ahead.
Those are called bundles. Are those the update bundles?
That's a great question. So where do bundles fit in? So bundle is a data format.
Mm-hmm.
It's a data format defined by Rauk, so it's really a Rauk bundle. And a Rauk bundle is a format defined by Rauk to carry an update set. And that update set can update multiple pieces wrapped in one big file.
Mm-hmm.
Technically, a bundle is a squashfs file system with a signature at the end, uh, with some um, with some cryptographic information to how the blocks relate to each other, and how that they can verify the integrity uh, of the entire file, but also at the block level. So you can read a single block and go and check a tree to verify that it has not been corrupted. And
Mm-hmm.
within a bundle, you can find, apart from things like a manifest that describes the bundle, apart from things like hooks that contain interactive code that will, like imperative code that will
Mm-hmm.
act during the update process, you will find a number of files that represent updates to individual slots. So slots are a concept that Rauk defines as well. I can quickly go on a small digression to describe them, or we can talk about Rauk in detail. But in essence, a Rauk bundle is a single file that is self-sufficient to update a device if the device kind of understands what's inside the bundle. Like you can think of it like a zip file on
Mm-hmm.
steroids that has information about what to do. And when Rauk gets a bundle, we can present a bundle to Rauk. Rauk would look at it, will verify the signatures, will verify compatibility, and will decide on where to copy the bundle onto the storage device and what to do afterwards. So effectively, it's a way for us to blast a completely new OS image onto the device. And this is
Mm-hmm.
closely tied to the way the device is partitioned. So the storage media is partitioned and what the actual partitions mean. And it's kind of different from a traditional Linux distribution, at least, and traditional like a Windows setup. It's a little bit closer to the modern Mac OS setup, where the entire OS is a one big read-only file system, and there's pieces of writable space that are like poked as holes in that file system. So, from a process point of view, when it's running on top of the system, you will see a mostly read-only file system everywhere, except for select locations. And some of these locations are ephemeral. So writes there are, going to a temporary file system in memory that is very small, and writes are obviously not persisted across reboots. And some of those go to actual persistent storage. And
Mm-hmm.
those are carefully selected mostly to limit wear of the storage medium. So you don't keep writing to actual storage. So that's a Rauk bundle. Like in essence, it's an archive which Rauk can consume to update the device. And we prepared, we both configure Rauk and the device, and we prepare the bundle so they are compatible. Like there's a million ways to make a Rauk bundle that is gonna be doing something, and we're using a very precise one so that it means something specific for our purposes.
Ah,
So
so a bundle, we could think about it as also an update for, I don't know, it's the update that Howbit would send, for example, to
yeah,
the
exactly,
device.
exactly. When
Yeah.
we look at the build system, BitBake has BigBake runs a recipe that constructs a Rauk bundle, which is coming from the meta Rauk layer, by the way. Then
Mm-hmm.
you have a Rauk, like you have a Rauk B file, so it's going to be like Rauk B something. Um, we take that file using Hogbit CTL, we upload it to Hogbit, then Hogbit has it. Some operator decides, hey, I want to send this update to this device. And then the device will discover this confirmation, will fetch the Rauk bundle from Hogbit, and will provide it to Rauk, and Rauk will do the rest along with sysota. So
Hmm.
yes, that's kind of like it's the payload that contains the entire update. It's not the
Okay.
entire image of the device, it's a specific file system that is crafted to be self-sufficient. So it has not only the applications, but also the kernel and the modules for the kernel and the bootloader as well. Even though the bootloader is technically somewhere else, we have a copy of it in the bundle so
Mm-hmm.
that we can actually take it out of the bundle and update the bootloader as well. So, it's like a self-sufficient payload that you can just give to a device to update.
Okay. And who takes care of like wrapping the bundle according to the appropriate OS? Like, is it Howbit?
Right now, so it's the build system. So just to be clear, right now all of this is Linux specific. The way Hogbit is used for updating Zephyr devices, which are
It's
like
different.
microcontrollers, is different. There's no
Mm-hmm.
Rauk involved. The bundles are gone. We still upload a file, but the meaning of that file is different.
Mm-hmm.
So, and we're not actually, I have personally not even explored this that much in detail. So I can tell you the high level
Yeah, yeah,
summary,
like.
but it's kind of the same in a different way. Like it's very very basic
Mm-hmm.
version of the same story. It's still a
Yeah.
self-sufficient payload, right? There's still something like Rauk on the device that you can present this to, which is MCU boot, and MCU boot is going to take it. It's going to perform really interesting operations, and then effectively at the end of the day, if it works, you're running the new thing. If it doesn't work, you're running the old thing. So there's a transactional atomic switch that you can control it, so it's resilient to power failures, resilient to like someone yanking the power cable or rebooting or doing something else. So it's supposed to be
Mm-hmm.
robust for being deployed in devices that you don't control all the time, right? So it's supposed to have this property. And Rauk doesn't fully have this property, but with sysota, well, it can. There's many ways of configuring it, and one of the ways we're doing it with sysota is actually to have this property. So we've been very careful to make sure that the way we update our devices is resilient to any kind of shattered power loss.
Mm-hmm.
or in general in failure, like you're updating a device, but it's just like a daily build and it's broken in some way, the device will be able to roll back automatically. So we're trying
Mm-hmm.
to be robust and like it's supposed to be industrial in the sense that it should not be fragile and it should be really made to be as reliable as we can get. There are some things that we know are less reliable because of external factors, like certain devices just do not support certain operations. For example, there's a board that has some boot firmware, literally on the
Mm-hmm.
board, like not an external start, like literally on the board. There's some EEPROM or some other flash chip that has some memory, and it has something like a BIOS. And some of the boards are like from the older design, and they just have one copy of the BIOS. So you can update the BIOS, but if you yank the power cable, the board is dead. You have to reprogram the chip externally, and or
Oh.
the board is gone. It just doesn't do anything.
Oh
Some
yeah,
newer
yeah.
devices are better, and they actually have enough memory for two BIOS copies, and they can do it kind of like an A/B or go back to a safe version. Or even if in the case of failed update, they have a small version that is never updated that is enough to just update unattendedly, like you like plug a USB key with a single file on a fat file system, and you turn it on pressing some button which is on the board, and it's going to update the BIOS even though the BIOS is actually erased because there's a piece that is read only that is capable of doing that. So they're like the levels of resiliency. Some of them are under our control because it's just software you can change. Some of them are a piece of the platform hardware or platform firmware that we just cannot control much. So, depending on what kind of device you're looking at, some of those things may be more or less reliable. And it just means that if you make a product out of that platform, you just need to be aware that maybe some of those things will just never update in the field. Maybe there will be a
Mm-hmm.
special, update pack an engineer can apply, but in general, this will stay fixed for the lifetime of the entire product. And this is typically the case in many products. So going back, we have NetOTA like being this a la carte repository. We have Hogbit being this fleet management solution and precise control, and we have Canto, which is coming in, which is a little bit more vague. But you can think about this as something that is kind of maybe I mispriced it actually because I have not fully explored Canto myself, and may have the wrong ideas. But I think so. Maybe Canto actually belongs to device services, but it's more of a generic solution that could update multiple different things. So we're looking at it for updating the applications as well, applications which live separately from the operating system. So right now
Mm-hmm.
we update effectively the operating system, and yes, you can technically put some applications in that OS image as well, but in general we don't want that because we want those applications to have a separate lifecycle, so you can update individual applications without maybe rebooting the device. That's where I think Canto will come in. So again, maybe it's so there's a lot of question marks here. Maybe it belongs somewhere else. So going to the device services, and a lot of the stack is existing code. There's really only one piece that we have introduced, which is this OTA. We have a lot of external factors. Let's starting with the bootloaders. Excuse me. We have PyBoot for the Raspberry Pi, which is a community board, but it's one that is very well known, readily available. And when people have first contact with the Nero, they typically don't have those industrial boards that we work with as well. And they may not be interested to work in a purely virtual environment where just, yes, it's a virtual machine, but updates in a virtual machine that is never going to, effectively live your build system are not so interesting. It technically works there as well, but it's kind of like you actually want to play with some hardware, and Raspberry Pi fits this bill very well. So it has
Mm-hmm.
its own unique constraints and own unique bootloader. But this is actually the first one we've supported, and we support it actually I think very well, like a lot better than pretty much every other Linux distribution out there. Some are already catching up, but we're actually ahead of the pack
And
here in a ways.
and the reason is because like Raspberry Pi is more used to the IoT land
So it
than.
depends. Like if you think about products, I think maybe not because
Mhm.
Raspberry Pi is really expensive if you think about it. Right?
Yeah.
It's a very powerful computer. It's a quirky computer in many ways, but it's really expensive. So if you look at an IoT thing
Mm-hmm.
in your home, it's going to be stripped down to bare essentials. Like it's going to be orders of magnitude cheaper than that Raspberry Pi. Um, Having fewer resources and effectively as few chips as possible. But Raspberry Pi is
Yeah.
something that like people have at home, and when they discover a Near and they just want to play with this is probably the device they will use it on. So that's why we want to
Mm-hmm.
have a very good story for the Raspberry Pi. So I mentioned PyBoot. PyBoot is really well supported now. There's going to be something I want to mark here. There's U-Boot, which is I'm actually in progress of adding support for U-Boots to SysOTA. There is Grub. that we support very well already. There's some still there's a one more thing to do, so I'm gonna like do a smaller start. There's one more thing to support grub correctly, and there's SD-boot, which is like a both question mark and a star, because we don't currently support it, and it's a question of how we want to support it, if at all. SD-boot is really interesting because it's the entry point to a lot of interesting technologies coming out of systemd that relate to boot security, that relate to the update process, that relate to resiliency. And if you don't have SD-boot, they're kind of disabled. You can't use them because it relies on what SD-boot provides. So maybe we'll support SD-boot. And it's really interesting. It's fairly simple. It's super nicely designed. Um, and says
What,
boot.
what is SD boot?
SD-boot is a
Excuse my.
systemd. Sure. So all of these are bootloaders. So pieces of code that run before we load Linux.
Mm-hmm.
They're usually started by the platform firmware. In case of PyBoot, it is literally the firmware on the board that is, it's like one and the same. In terms of U-boot, there's something usually before U-boot. So U-boot is not the first piece of code that executes. There's like something in the CPU that's in the ROM mask. Then it
Mm-hmm.
loads something else, and it loads something else, and then it loads U-boot, and then U-boot either loads something else or maybe loads Linux already. It's like a big sandwich,
Yeah, these series. Okay.
and it's done for reasons like some of these things present an interesting interface. For instance, you would like to have like EFI stack available. So you have all kinds of
Mm-hmm.
EFI services. You can rely on the API. You have a consistent behavior from user space, hopefully. So maybe people actually want to provide something which like provides the CFI shim or EFI interface, but there's some other bootloader they cannot change that is provided by the board manufacturer or the board support package, so they kind of put them in the sequence. In our case, um, all of them are kind of standalone. We have pyboot just booting the kernel, we have uboot just booting the kernel, but it's not the first bootloader, so there's something before that. On most
Mm-hmm.
platforms, we have Grub, which is booted by the platform firmware on x86, and maybe actually something we'll see on ARM as well. We'll see. It's really like a very long and complex discussion of how and exactly where we want to do things. Because on
Mm-hmm.
one hand side, we have to trade practicality. Something that just has to actually work in realistic time frames. On the other hand side, we have some architecture we would like to have, which is consistent, works across different architectures, and has interesting features. And it's kind of
Mm-hmm.
difficult. You can't have like the cake and eat it too, unfortunately. And SD-boot is like that. It's part of systemd from it comes from the systemd project, but it is technically not a program that runs in user space. It's not a program that runs in the kernel. It's something that loads the kernel. So it's an EFI
Okay.
application. EFI is like an entire operating system that runs before you actually boot your operating system. It has a
Mm-hmm.
lot of different features. You can run actual applications. You can run an EFI shell, just play around there. I even saw someone port Doom to EFI, so you can actually run Doom before you
Wow.
boot your OS. So why not? So SD-boot is another EFI application that has a very good implementation of a very simple and nice protocol that systemd guys have devised. That has some good properties, and in particular, it has a definition of a declarative location on the EFI system partition or ESP, where you will discover EFI files that contain within one file the kernel, the initRD, maybe some metadata, and signatures. And the reason this is interesting is that you can then ask the firmware to boot SD-boot. SD-boot can be signed, can be trusted by the firmware. Then
Mm-hmm.
SD-boot will perform verifications and again measure and verify the signatures. So measure is like look at the actual thing that you got, and verify signatures is to look at that and check if you like it or not. So measure and verify the kernel and load it, and then the kernel continues the boot process, finds the root file system, finds all the other interesting file systems and mounts things. And when you do that with SD-boot, there are some other benefits um, on how this whole vision of the system booting and the updates coming in work with secure boot environments. So when the system has some kind of root of trust and trusts only some of the software, and then the software can change, and maybe the trust chain can change as well. So it's kind of sophisticated. How can most people misbehave? How can fail? What the attack
Mm-hmm.
surfaces are, and just integrating SD-boot, I think, would be a very good way for us to get a lot of those good benefits without just reinventing a wheel, because it's a really good wheel to have. So these are the bootloaders. And
Mm-hmm.
again, so the one without the gray asterisk are supported. So it's really just pybut and grub. Grub is kind of supported, but there's one more to do on it. So it works today, but there's one more piece that needs work on, which is specifically updating the grub EFI application itself. So actually, I hope to do this. Maybe even this month. We'll see if it spills to the next month. It's one of my last top priorities to wrap up the entire Linux side. We have Rauk, which is a user space service. It just sits on the
Mm-hmm.
machine. You can talk to it using dbus. Dbus
Mm-hmm.
is an IPC that is very common on Linux. And it is something that effectively has the following idea. It defines a world with slots. So you can have different slots of multiple types. You can have multiple slots of one type. That's actually the point. And Rauk can be presented with a bundle, and then we'll choose, okay, inside the bundle, I see some payload for this type of slot and this type of slot. I will figure out how to use unused slots to write the new bundle contents
Mm-hmm.
and reconfigure the system so we'll be able to use those new things. So in essence, in kind of generalized AB, it can be ABC or whatever. It can be AB recovery. It's really flexible. It has support for all kinds of formats inside. We're actually using a really dumb format by just blasting the entire image onto storage into a specific slot. A slot is
Mm-hmm.
just a partition in this case.
Okay.
But it can do a lot of things. It can update individual files. It can update files within the file system. It has, it has lots of bells and whistles. It has support for like a trust root of trust itself, so you can install like a certificate or like a key that will use to verify the things that Rauk will try to install. And Rauk has really good cryptographic code that also works with the kernel, so that the actual update process can be trustworthy. You cannot really corrupt the bundle and hope for it to install. So that's really nice. And Rauk has been around for a long while. It's been integrated into many products. There's like we're using Rauk Cockpit Updater, which is a separate piece of program that talks to Rauk using Rauk dbus APIs and talks to Hogbit using the DDI HTTP APIs in Hogbit. So
Mm-hmm.
there's actually a lot of interaction around Rauk. So there's existing, people understand what Rauk kind of does. There's just a lot of different tooling around it. So reusing Rauk for us was really useful. Rauk can actually drive bootloaders itself, but we're not
Mm-hmm.
using that because Rauk has slightly different semantics. And I wanted to have, when we were designing this a year and a half ago, we wanted to have a slightly stronger semantics. So we actually use sysota to control the boot process. So every time Rauk installs a bundle and has a piece of the process where it needs to reconfigure the bootloader again, it has a pluggable piece here, and we actually plug sysota here. So sysota sits both beneath Rauk, where it is being used as the boot process configurator, and slightly above Rauk when it's using Rauk itself as a service. So when you can tell sysota to do something, and sysota will actually
Mm-hmm.
say, okay, I've done part of it, I'm going to relay the rest to Rauk. So it's kind of like they interact together. So
And sys OTA, like in simple words, how can
So
I think
sysota is the
about it?
next slide. It's a
Oh,
piece. So
okay.
in simple words, it's a piece we've introduced to the stack to have a level of control. So when something is not doing exactly what you want in these things, you can either go upstream and convince them that this is something you like to do. Maybe they will agree with the vision, maybe they'll disagree. You have to write the patch. If you write the patch for a specific version, maybe they disagree and you actually want to have something else and you kind of diverge on the vision. They have to maintain the patch across the version. So Sysoti is the piece where we can control and have our way to do interesting things without really going uphill with all kinds of like we would like to do something new, but we need to tell everyone else to do something differently, and it just kind of doesn't really work very well. So Sysoti is a piece that can effectively give us this place of control, and over time, like either integrate with something or replace something so that the entire architecture is doing exactly what we want.
Mm-hmm.
So we're going to go into SOTA, but you can see like it's going to have interaction with the application updates. So it's going to coordinate. So when you maybe there's an application performing something like I don't know, you're an example from my past is you're flying a drone, so you don't want to reboot the kernel right now just because there's an update, right? So it has some kind of interaction with applications. There's an interaction with the firmware update process, which is a completely different stack. It's a separate piece of technology. I actually have
Mm-hmm.
not listed it here. I should have. So let me go back there and maybe make some more space here. Oh man, I don't know. I'll just erase this and just gonna put uh, at firmware. Oh, wrong color. Firmware update manager. So that's another piece of the stack that is really relevant. It's a really good piece of the stack, and we just want to integrate with it well. firmware update. I forgot what the acronym was. It's like a really confusing acronym. I think firmware up DMGR or something. Anyway, and it's written in C as well. So it's the central point where all these things, where all these things meet, I think. Okay. So that's how I see sysota. So it's gonna interact with applications. It's gonna interact with the firmware update process. It's gonna interact with the boot system, and it has like legs or tentacles that reach out to different places. So it like interacts with Rauk a little bit, interacts with NetOTA a little bit. I hope it will interact with Hogbit for reasons I will explain in a moment a little bit. And it also has a piece where it can, because of the transactionality logic, take a snapshot of the entire OS and restore it if something fails, just around the
Mm-hmm.
update. So when just before you, as you're shutting down to update, you will take a backup of the entire OS state, which is actually super tiny in our case. And then if you everything works fine, that's it. You just remove the backup. If something goes badly on the recovering boot, when you're aware you have been effectively booting into an older version or the version you came from, you will notice that okay, I actually need to restore the backup. So this is something that
Mm-hmm.
sysota is responsible for as well.
So when I followed the videos and built the Oniro base image, we literally installed sysota as well when we
Sysota
built
was
it.
inside that. Yeah, yeah, yeah. It's one
Okay.
file. It's fairly simple. There's some config files as well. There's some symlinks, so it's easy to start certain pieces. But Sysota is
Mm-hmm.
really one file, and some interactions with all the other pieces. It's not a standalone piece of software. So let me switch colors. Okay. So we have Firmware Update Manager. We have Rauk. I did not really discuss Firmware Update Manager, so I just put it here, but we can discuss it as well. Sysota we'll discuss in a moment. And before that, there's Rauk Cockpit Updater, which is a C program which sits between it sits on the device. It has its own configuration file that effectively tells it how to talk to Hogbit, and it keeps
Mm-hmm.
talking to Hogbit using the DDI APIs. So that's DDI. Maybe I
Ah,
can
so this is the actual
DDI.
update.
This is the actual thing that discovers there's an update,
Yeah.
takes it, and relays it to the next component, which is in this case Rauk.
Okay.
So it talks to Hogbit in the cloud. And this is the stack that lives on the device. And now I think we can really discuss sysota and maybe later on firmware update manager briefly. So hold on, actually one more thing, just a quick overview of what is everything written in. So build system is like a mixture of Python and Shell with a really weird flavor of Python and Shell, which is specific to Yocto.
Mm-hmm.
Like BitBig has its own kind of language that is this weird mixture. So if you know Python, you know Shell, you will still learn something new in BitBig. I think West is in Python, but I just don't know. Hogbit is written in Go. Like pretty much everything I write is written in Go by default. NetOTA is written in Go. Canto is written in Go as well.
Hmm.
Hogbit is written in Java. And on the device, most of the stuff is written in C. Unfortunately, except for sysota, which is written in Go. And there are several other updaters for like Rauk. One of them is written in Python, but I didn't really like it, mostly because it's Python and dependencies. And I don't think we actually want to introduce those. And I think there may be something for Hogbit directly, maybe not to Rock, but just talking to Hogbit, but that's written in Java, so it would be fairly huge. So we also have not used that. So most C, some Go, a little bit of Java in Hogbit itself. Which is kind of traditional embedded, but this is really changing. I don't think C is going to be the dominant language in our environment for a long while. We'll see a lot of interesting new languages like push it out little by little. So let's look at sysota. So again,
Mm-hmm.
it's this octopus that has all kinds of tentacles that go everywhere. So it talks to Rauk in the following way. So Rauk has a concept of hooks and handlers. Hooks are something you can put in a bundle. We actually don't use any of those. We should probably configure Rauk to disable those so you cannot abuse them. And has handlers which you can put on a system to interact, replace, or extend a piece of what Rauk is doing by itself. And we're
Mm-hmm.
using handlers a lot. So we're using three handlers, the pre-install and post-install handlers. So whenever Rauk is presented with a bundle to update, we run some code just before and just after. I don't
Mm-hmm.
know. I will explain why we do that and how that interacts with everything else. And the major one is the bootloader handler. I forgot what the actual name was. Effectively, we replace the entire boot logic in Rauk with our own logic. And it's called, we just say we have a custom bootloader type, and there's the boot handler that implements a protocol defined by RAUC and that is implemented inside sysota. So sysota is a system service. It runs and presents a bunch of dbus APIs. And all of these things are either invoking those dbus APIs or are miniature programs because they have to be exec by RAUC because that's the protocol format that again invoke those APIs. So the point is that the clients that talk to sysota do not perform the operations. There's only one process that's actually performing those operations. So
Mm-hmm.
we can assure like mutual exclusion, and it's very easy to understand what's going on because you can assume that pretty much all the operations are done inside one process, and you can grab a lock, you can do things in memory, and then you can write them down. You don't have to synchronize with everything. It's a fairly simple model for the point of view of understanding how it behaves. There are some downsides, and we actually wish to split this OTA into several system services, mostly because some of those are not going to be used on a given device, and we like to have um, permissions that are a little bit less resources. That's actually secondary, but primary reason is that each of these services will have different permissions of the system. So for
Mm-hmm.
instance, there will be a piece that can interact with the bootloader, and that piece will actually have permissions to write to the bootloader space, and Sysota in general will not. And we're just going to compartmentalize all these pieces into their own mini sandboxes using systemd, which has really nice features for that, so that in essence the system security is better because it's more difficult to attack a piece where it's comprised out of pieces that talk to each other but in general have as minimal permissions themselves as possible. So
Okay.
perhaps the part that can touch the bootloader will not be ever able to talk to the network, for instance. So you can
Mm-hmm.
avoid some kind of attacks. Like, it's not written in C, so it's a lot more difficult to attack and exploit, but it's just a good practice. So there's pieces that talk to RAUC, and these are pre-install, post-install.
I imagine they have like certain protocols to
Yeah,
communicate.
absolutely. These are defined by
Mm-hmm.
RAUC, and we have implemented them. We have pretty nice tests for that. Like, Sysoti is the oldest project here that I have started, and it has the most testing muscle behind it. Like Cockpit CTL and NetOTAD have completely different levels of polish. So I think this one is the best from the point of view of the amount of effort that went into it. And a boot protocol. I'm just gonna call it boot handler. Yeah, and this is effectively when RAUC calls back to SysOTA to do certain things.
Mm-hmm.
So it also has a NetOTA client, which is something I think we should easily be able to split out, and doing so will make the architecture a lot cleaner. So it's effectively a small piece that has its own configuration and state. You can configure it to look at a specific NetOTA server in the cloud. You can have some preferences, like you wish to follow a specific package, and within this package, you would like to follow a specific stability or feature stream. There's this level of indirection when you want to have, like in classical packaging, right? If you want a package, there's only one version available. If you
Mm-hmm.
want a newer version, you have to upgrade the entire OS. Nowadays, there's a trend of having like multiple different versions of the same package available at the same time, so at least you can choose. Maybe sometimes you can even co-install at the same time. So for instance, you can have Firefox nightly, right? And you can choose to
Mm-hmm.
install it. We can maybe have it as your only browser, but at least the choice of available Firefox versions exists, right? And in theory, you can go all and check all the past versions. And this was traditionally done for like desktop OSs because people would just download the installer package. But it was not so for any of the Linux distributions because of the complex dependency stacks between them and things just not working well when you have all these choices. Um, but now people are kind of realizing that just having this whole lockstep doesn't actually work very well for many reasons. It's just not sustainable. It's not what users want. So NetOTA follows this trend in introducing an indirection. So for every package, let's say for every OS version that you have to have that you may have in NetOTA, you can actually have multiple versions of this published at the same time and available at the same time. So a device can choose to upgrade to a specific published version. So you cannot choose any version. So the point is that you cannot like trick someone to say, oh, you have to install this version because that version is exploitable and they're going to attack you. You can only choose what the developers have published, but the developers have freedom to publish as many versions at the same time and maintain them at the same time.
Huh.
So you can have like an LTS, like a long-term support version that updates very infrequently, once in a few years, that has continuous support and keeps receiving updates but has maybe fewer features because it's maybe a few years old. And you can have like a updating version that is a little bit less supported, maybe has a very short support window, but has a lot of new features. And you can have like things like going all the way to the edge. You can have like super fresh build that literally was built a few hours ago in the CI environment. No one actually ever knows if it even works correctly, apart from some basic automated testing. But yeah, you can actually have a device and tell that single device to follow that latest daily build and see what's the latest features. So for instance, you're trying to check if something important was fixed, if a bug was fixed, because you're having both a production environment and you're having like a staging environment where you're gating changes from the software manufacturer so that you can deploy them in your production fleet. So you can have some canary devices, you can have some devices where you can interactively explore things. So you have this flexibility per device. So the device both has state, so it knows what it has installed, and has configuration, so it knows its own preferences and can talk to NetOTA to retrieve those. So NetOTA client is actually built into SysOTA, but I would like to conceptually split it out so you can choose to enable it or not. And the reason for that is that we can also have a Hogbit client. Right now,
Mm-hmm.
our Hogbit client is this guy. So it's Rauk Hogbit Updater. It's just right here.
Yeah.
But there's some problems with it, and I don't think it's worth investing in it. It's a program written in C. It's fairly tedious to write this sort of software in C, like fetching things from the network, verifying stuff, like not even verifying much, but like this sort of code you just don't write in C. If you can have something higher level, just writing it is going to be 10 times faster and you're going to have 10 times fewer bugs related to memory safety, right? Related to just undefined, what is undefined behavior, right?
Mm-hmm.
And it's fairly simple, right? You just need to know where to connect, how to authenticate, and when you know there's something to do, you just follow the instructions, like you just download something and then hand it over to Rauk. So I think this is something we're going to replace. The reason I actually want to replace it with a first party feature in SysOTA is so that we can have better understanding of the transactionality model. So right
Okay.
now, if you've been following any of the things I've been doing and publishing all the videos, you can see that during the update process, how Hogbit is happy and thinks the device has updated even before the device has rebooted and confirmed this works. So you can have a device that checks, updates, reboots, finds the state unhealthy or cannot actually update, gets rebooted manually or gets rebooted by a watchdog and rolls back. But Hogbit thinks it's okay. Hogbit thinks it's
Oh,
already updated because it doesn't have this sort of interaction. This
yeah.
just the problem is this client is fairly basic. So I would like to take that client at some point and integrate it into SysOTA, where it can actually have this full understanding of what's going on with the, still doing the same thing, really downloading a file and giving it off to Rauk.
Yeah.
So not even SysOTA specific, but the difference is that the set of time it looks at the process would be longer. So it would include the reboot in the middle and not include it right now.
Mm-hmm.
So again, I see SysOTA as having those pieces that integrate with different technologies over time, and you will be able to, as a device vendor or someone who tries to build a product, you'll be able to tick off the boxes you want, right? For instance, Hogbit doesn't make sense if you're producing light bulbs. Like smart light bulbs with Hogbit makes completely no sense. You don't
Mm-hmm.
want to reboot a light bulb in someone's home. It's supposed to be their light bulb. The best you can do is to just set this light bulb for automatic updates and just leave it at that. And maybe over time introduce an app where you can control things, right? So this is
Mm-hmm.
where I think a NetOTA like model fits better. So those things are kind of mutually exclusive. You really only want to have one or the other. So that's why I think over time we will have those separated applications and their separate state and their separate configuration that you can configure into a specific image, or even have both built in, but still when you provision the device to be something more specific, when you initially configure it to do something, then you can choose which parts you enable. So I already mentioned system state backup and restore. That's not landed. I've like 80% of it is landed, but technically it's not enabled. So there's a little bit of more work to do, and this work will definitely not happen this month. It may happen in the next couple of months. Will depends on how we order things with relation to working on Zephyr bits. So it's not really high priority. We don't have like a customer who absolutely demands this right now. It's
Mm-hmm.
something we want to have because it's a nice feature, because it gives you this stability to say that unless you create an update which literally destroys flash memory on your device, you should be able to recover from most fail updates. Like Again, the only exception is that you
The old.
maliciously put something which will just keep erasing things left and right.
Oh yeah.
Well, we cannot defend against that. But if it's just like a mistake or something doesn't work, you should be able to reliably go back, even, and this is important, even if the data format changes, right? Maybe you've updated like from last year's version to this year's version, and all the configuration files have changed. And you have updated your configuration files because you put some logic
Mm-hmm.
into the update bundle, but then, whoa, doesn't work. And it's actually a critical failure. So people want to roll back, and devices will roll back automatically, but they roll back automatically, but the old version just cannot understand the new formats.
Yeah.
Everything will be broken. Like you cannot go forward, cannot go back. You're just stuck in a terrible place. So this is an
Yeah.
important piece that gets us out of this situation. So when the device goes back and goes back to the old data, and you can actually keep working until someone realizes the updates are rolling back and are failing, debugs the problem, analyzes the problem, and presents an update that actually works and will be accepted. So it's an important conceptual piece. So you have the boot transactions, which is a piece that is effectively you could kind of detach it from everything else, detach it from the entire rest of the stack, which controls the bootloaders and can have this commit, rollback, update transaction model where you can begin a transaction, do some operations, then reboot, and then you decide if you want to commit, or if you don't commit, it actually rollbacks automatically at some point. There's this guarantee that it will be able to roll back. So this is a kind of like a
Nice.
separate piece, and I think separating it out conceptually may make sense, may not make sense, but it's like a very distinct layer inside the code. And there's two things that have a star here because we've completely not touched this topic, but we know we're gonna interact with those pieces, so they're in the scope of the same project. Is the updating of the firmware itself, like like your BIOS or your cable
Mm.
mode, sorry, not cable mode, like your GSM modem that some boards may have. It has its own OS inside of the modem effectively, and there's a logic to update that. But this has to be coordinated with the rest of the system. So there will be definitely something here that is aware of those interactions. Like I don't know, I'm just gonna say like BIOS in air quotes because it's called this way for historic reasons mostly. Maybe like modems, maybe even storage, but in general all kinds of stuff because all
Mm-hmm.
kinds of stuff has updatable pieces. And there's the firmware update manager firmware update manager program and LVFS. So LVFS is this thing. It's like so LVFS is kind of here, except it's a third-party service operated by either Red Hat or the Linux Foundation. I'm not sure, which is like a platform agnostic place where any hardware manufacturer can come and start publishing updates for their devices, like for the
Oh,
firmware on their
nice.
devices. So when you buy like a ThinkPad or a Dell laptop or you even like a Logitech mouse, and there's a firmware update for your mouse or for the little dongle that the mouse comes with, this is published to LVFS, and there are multiple different clients that interact with. Like there's a graphical piece of the client, and then
Mm-hmm.
there's the service side of the client, which is the firm update manager, which can actually upgrade those devices. And it really can upgrade on a modern laptop like half a dozen devices, like embedded controllers. On my laptop, it has updated like the Thunderbolt controller, the embedded platform controller, um, the SSD controller, the Wi-Fi chip, the Ethernet chip. It has really updated pretty much everything that the system
Wow.
has. And even later on, I've connected my Thunderbolt dock and upgraded the dock, which had like 4 pieces inside, which are separately updatable. So it's a very interesting
Wow.
project, really nicely done, with really a lot of community momentum and industry momentum as well. So it's super nice to integrate with that and have access to expose these updates as well. So in the central place again, I think Sysot is going to be the gateway to looking at the system and the movable pieces within the system. And lastly, the app update coordination, which is a very big question mark for a couple of reasons. So first of all, as a year, we're just really defining now how we see for this year cycle, how we see the application ecosystem. Like you're gonna effectively right now, I think the idea is we're gonna run Podman on our devices. So all applications will run in containers. There's going to be some lifecycle for these containers. There will be some way to manage that. And again, this is, I think, where Canto a little bit comes in. So we will see. But the idea, there will be something that has a bunch of features and that you can control from SysOTA maybe, or we can
But
interact with SysOTA.
but
But
these apps, sorry,
yeah,
these apps are like the, I don't know, the app that connects devices to each other, for
So it could
example.
be whatever your product is. So if it's like a smart, like let's say you have bought a gateway or router. So maybe it's the entire user interface, maybe it's the Wi-Fi sharing application, maybe there's like a miniature app store inside your Wi-Fi router that says,
Mm-hmm.
"Oh, I want to install like Google Cloud services for printing," or I don't know, I want to install like a Plex server, or I want to install like
Mm-hmm.
it can come up like it's really a computer with a market. And all of these applications, whether they're first party coming from the system vendor itself, system pieces, or whether they're third party and just come from people who want to put applications onto those devices, they will have their own life cycle. They will be able to update individually. They will not be able to interact with the rest of the system in an unconstrained way. So there will be a sandbox around them. And importantly, they will not be able to break the system in an like uncontrolled way.
Mm-hmm.
So you should not have a situation when you upgrade a device. Sorry, when you have a device, when you upgrade a single application of that device, and that upgrades a library, and then suddenly another process breaks because it required the old version of that library because the
Oh
API
yeah.
is different. So they're going to be like separated, compartment. Blah, I can't spell that. I can't pronounce that. It's a terrible word. So they're going to be separated into containers, and these containers are effectively going to be they're going to live their own lives, but they will have some interactions with the rest of the system. So I think
So
mostly around,
each app,
yeah.
so each app lives in a different container, if I got
Or you can
correct.
have a container with multiple apps. You can think of it as a container, and the container has a bunch of stuff running inside that. Maybe it's one
Mm-hmm.
app, maybe it's like a small zoo of apps, but I think the general level of granularity from the rest of the system point of view, it will be just a container, and those
Mm-hmm.
containers will have to have a way to interact with some of the hardware on the device.
Yeah.
They also have to have a way to interact with some of the system services. And this is where I think, from our point of view, one of the first interactions I would like to definitely have an idea on how to model is to interact, is to constrain the updates of the entire OS. So you wish to not interact you wish to not interrupt the user, like maybe like it's a TV, you're watching a movie on Netflix app, and now there's a system update and it's set for automatic update, so we'll maybe update when you switch the TV off into soft mode. It's like a soft off mode, but the Netflix app would like to prevent the system update from running just right now because it's not super urgent and someone's watching a movie. So for good experience, or a drone is flying or something like this sort, there will be some kind of, please hold on, maybe I'm
Control.
doing something else and come back later. But obviously, you have to have some kind of system to make it difficult to abuse. So an app cannot just forever say no.
So,
It,
so the main difference between, like, let's say third party applications that exist before and the third party apps that are gonna exist on Oniro is just how they get updated, how they use resources.
it's also all of this stuff is like Lego bricks we're giving out. We're not prescribing a way to run your devices. Oniro is
Mm-hmm.
not building a product that is in itself an end user product. Oniro builds the 80% product where you can come, like Oniro really builds a platform where you can
Mm-hmm.
take this platform and have 80% of your product done, and then only put
Ah,
the stuff you
okay.
care about, right? So if
Mm-hmm.
you're like a drone vendor, you have a lot of problems with just manufacturing the drone, designing the drone, writing software for the visual tracking, or I don't know, GPS navigation. I really don't know what drones do nowadays. I don't have one, but this is your problem domain, right? This is You're not
Mm-hmm.
really interested in, okay, but which LTS version of Linux do we stick on, or what kind of patches? So like this is hopefully not the problem you're solving, and
Mm-hmm.
you're looking for shortcuts would get you what you want to have, like you want to put some specific applications on top of a really stable platform that is maintained by someone else, and have a way to make a product out of that. And once the product
Mm-hmm.
ships, have a way to keep updating it in a safe and secure way, right? And
Mm-hmm.
reliable way, so you don't have people coming back with products that have died because of the update, so that you can keep innovating on the software or fixing bugs in the software without being the entire platform manufacturer. So maintaining platforms is expensive, so it's just something that in here will
Mm-hmm.
offset for people who make actual products. So
Ah, okay.
depending on what they want to do, maybe they will put their app in the container, maybe they will put it in like they will screw containers, excuse my language. They will just put it directly into the operating system image, and every time you actually want to update, the device will reboot, and that's fine. Maybe that's fine for their use case. Maybe you have a
Okay.
coffee machine, and yeah, I mean, it's gonna blink, it's gonna go brrr for a while, and a minute later it's up to date, and that happens like 3 times a year. That's fine, it doesn't matter. So
Mm-hmm.
it depends on what you're building, and we will not be able to actually say you must use a container and it must be wrapped in Podman. Maybe someone will use something else. We are only providing reference stacks that are integrated well and are tested well, and we can stand behind them, and people can mix, like people can choose the entire stack we like recommend, or they can deviate as much as they like. It's all open source.
Oh,
There's
that's
like,
super cool because like instead of like this, we're not competing anymore. We're just
yeah,
collaborating. Let's say.
yeah, I think there's like, if there's an analogy I think is appropriate in a way, is that this is a little bit like Linaro. If you're familiar with
Mm-hmm.
Linaro, it was founded by a lot of companies that just compete with each other. They literally compete with one another,
Mm-hmm.
but within each of these companies, there's a part that they really need, but no one is going to them to buy their silicon because they have that part. The part is just necessary. It's like a foundation. You're building nice homes. People are looking at the shape of the house, at the furniture, but you need a foundation, and everyone has a foundation. The foundation is boring in a way, and the fact that everyone's building a different foundation is costly and difficult because people actually manufacture any of them, have to have different tooling. Maybe it's a bad analogy at some point, but Naro was a company, it was an organization started by competing companies, so they could separate the pieces where they can work together on things
Mm-hmm.
that are boring from their point of view but necessary, and when competing is actually hurting their business because it costs them more money, getting them worse results when they just compete and reinvent the wheel and have two different wheels that don't work together. Now the
Mm-hmm.
public road system has to have two different types of roads, that doesn't work. And as an analogy again, and the place where they do compete, and that's not in the narrow. So I think Oniro has this kind of flavor where people will come to Oniro to just benefit from the baseline platform, which
Mm-hmm.
is just providing the boring bits. But those boring bits are vast and expensive to build if you want to build them yourself. Or I mean, everything is open source, but there's obviously the difference when it breaks. When it breaks, then you can actually, hey, Nero, this is broken, and you said this would work, and we'll fix it. Versus, hey, it's broken, and someone on the mailing list will say, yeah, fix it. So I think this is what we're trying to do. We're trying to provide a nice platform which has nicely opinionated, sometimes less opinionated pieces that work well together, getting feedback from all the partners who participate in Uniro. They can influence obviously all those choices and all those decisions. They can participate in development. They share some of the costs, but they get all of the benefits. So everyone participating gets all of the benefits. So
Mm-hmm.
some of the things we design and some of the things we make, people may end up not using. Some of them, they will end up using them. So it's like a very flexible architecture, and everything we do, even like looking at the application, not even update mechanism, but the application runtime, that is something that people will probably deviate on because there will be a lot of different things they would like to try. There will be some nice
Mm-hmm.
small project that is very nicely done. It doesn't fit like into every problem space, but maybe for some specific products it fits really well. So instead of like taking Podman or taking like K3s or the whole of Kubernetes, which is very complicated, they will do something small and lean that works well for them, and that's fine. Like
Mm-hmm.
Oniro is a source-based distribution, so whatever we provide is really source code, not a binary that you take. All the binaries we produce are just examples or reference builds for testing, or things that we kind of expect you to build as a even as a user who's tinkering with it, like a developer who's interested and is just tinkering with it. We're not like Debian or not like Windows, who's providing binaries which are end products. So
Mm-hmm.
this is like a big distinction for us.
Oh, okay. Yeah, that's such a cool. It's probably the coolest thing. It's like,
So that's the overview of the
yeah.
parts that I think we will be mostly working on. There's a lot of other
Mm-hmm.
parts. There's like the Zephyr site, which I have not discussed yet, and Zephyr kind of lives here as another thing, which is like devices, but I'm going to just say Zephyr. It's going to have its own thing. It's going to talk to the cloud. It's going to like there's going to be pieces coming out of the build system, but it's going to have its different. The pieces here are going to be completely different. There's going to be
Mm-hmm.
no sysota, no RAUC, no firmware update manager. It's just like there's a couple of different things here, and we will look at Zephyr, but I think we have enough for now.
Sure. So, so yeah, I So to be honest, like most of this stuff are completely new to me, and yeah, I would. I'm not sure like where to start. Getting to learn and.
So I think for now, the easiest way, like in my opinion, the difficulty is as follows. This is like one, this is easiest. This
Mm-hmm.
is two or three. This is kind of hard because it's vast. It's really vast, and it's like a very large shell script.
Mm-hmm.
It's not like you can run an IDE, click on something, and it will tell you, oh, it's a symbol. It's using these places. I will cross-reference. No, it just no. It's like it's very dynamic, hard to understand how things work. Um, a lot of things which are unique to this piece that are just nowhere else. So I'd say this is difficulty-wise two or three, and this is a whole range, but maybe this is 2 to 4, but not because of the coding, but because of just a little bit of language. Like C is kind of more difficult,
Mm-hmm.
well, maybe not to read, but definitely to write. And maybe the difficulties here are slightly different. They like just deal with complex stuff. So you're going to look at, you know, the piece of code and it's doing something, trying to figure out why, and now, oh, just go read the UFI spec, and that's like 500 pages of things to read
Wow.
and cross-reference, and then
Mm-hmm.
there's ARM, architecture manuals are thousands of pages,
Mm-hmm.
and all of this stuff is just refers to complex pieces of technology, like complex standards. Some of these things are actually easy. I would say like sysOTA is self-sufficient, self-defined, doesn't interact with many things, so maybe it's like 1.5. So those are easier. Rock is nicely done, I think. So I would say it's just 2 because it's written in C and it's doing a lot with crypto, and it's like not crypto crap, with cryptography, not cryptocurrency, and it's dealing with kernel interfaces, and that's a fairly low-level piece of code. So there's a little bit more difficult. This I would say is like 1.5 as well. It's just networking code in C. Firmware update managers, I'm not gonna. We fortunately don't have to write any extensions for it because some of that it's nicely done, but it's I would say it's 3 or more. It's fairly interesting because it's dealing with all kinds of different protocols of how things update, and it's a fairly sophisticated piece of software. So I think you should start with looking at Hogbit, not as a source code because that's a vast Java app, and we at this moment don't care about extending it from the inside. We're just trying to integrate with it well, and look at Hogbit CTL, which is really the Go Hogbit library.
Mm-hmm.
This is one or two maybe. And the reason for that is there's a lot of work in these two areas, like the intersection between Hogbit and Hogbit CTL, and soon on a device like a client that talks to Hogbit using one of the two APIs. I think there's going to be a lot of code there that we need to either adapt or just improve. Some existing code, some new code, and I think this is easy because it stays out of the C-level languages, just so much easier to actually work with on a daily basis. So this is Go and
Mm-hmm.
Java, and will get you like 80% of the way towards understanding this thing that I was just sketching here. Actually how they look like, actually where to find them, and to expose you to all these pieces. And after that, I think we should look at some of the device services on Linux. I think Zephyr will leave for the like later parts of the year, because it's slightly a big unknown on exactly what we want to pursue there. We have done some initial investigation. We know what is supported. The question is, what do we do about the parts where not supported? So we need to have
Oh
a
yeah.
brainstorming discussion of what the goal should be for this year. We want to introduce a new piece, like a bridge that talks between, like it's like a bridge between two different protocols, like upgrading over
Mm-hmm.
Bluetooth or something of this sort. We need to explore. We need to see what's there. And I personally have done much. I have basically no experience with Zephyr. And on our team, I think Zephyr is something we have less experience in general. Like we have some people who have been doing Zephyr for a while now, and that's good, and they can definitely help a lot. But in general, looking across everyone, there's definitely like a step down from their general Linux expertise. So
Mm-hmm.
Zephyr is just a little bit more challenging. So and sysOTA, there's a lot of things that we can just little things that we can chip, like add little features, little bugs, little improvements. Like the Rauk pieces are currently there's like a miniature Rauk library written in Go inside this OTA project that would be nice to like split out improve in quality a little bit, provide nice APIs for, and then just use backends to OTA. So it's like a well-defined component you can look at, you can understand what it's doing, you can just write it. It's a done deal. It's like it has bounds, right? It's not going to be
Mm-hmm.
ever expanding. It has well-defined feature set. So having it done completely would be nice because right now it's like 20% done inside this OTA, just because there was no good Rauk Go bindings that I found at the time, and even those I found were just too basic. Um, so having a nice Rauk library written in Go that we can use in SysOT and other places would be a good thing. So it's like there's lots of those miniature projects. If you look at the
Mm-hmm.
repositories and the issues associated with them, I I was trying to come up with some ideas of how I see, there's like a missing feature here or a missing thing here. There's a lot of things to just effectively start picking up and just
Mm-hmm.
trying to use as a learning exercise, right? You don't know the language very well, you don't know the project very well, but let's look at this. Let's try to see how much I can do, just how much I can learn by trying to figure out how to do this specific piece. And maybe next week we can look at those together and find a few that you can look at
Mm-hmm.
yourself and just use them as a uh, driving mechanism to explore the code in depth and see what's going on. So as I said before, I think I said before, I'm going to mostly look at U-boot support. So that's very closely, like very, very simple. I just need to get it done and test this. I want to look at, where is this? It was actually here. I want to look at, no, it was back here, sorry. Here at grub. So I want to get rid of the star. I just want to make sure we can upgrade the grub binary itself in a way that is safe and reliable. And when that's done, like in my opinion, like the Linux side of the OTA will be 90% done, and I think we can
Oh.
have we can like 90% done in the sense that there are some things that we would still want to do that's not in the 10%.
Mm-hmm.
That 10% is the things that I think we should do to be in a position where we can stand behind this and say there's nothing really wrong with this stack. There's nothing really
Yeah.
broken about it. There's nothing really majorly missing. And I think the 10% will be around these guys. So we will be able to, and over time, figure out how we want to interact with the application updates and firmware update processes. Right now, it's okay not to do that because application updates are just not even a thing because we don't even have this thing integrated yet, and
Mm-hmm.
firmware updates are complicated because at least on the platforms that we have right now, the reference platforms, we don't really have anything to update to. So it's a problematic thing. Like some devices just don't have firmware for you to put on them. Like the vendor makes one firmware file, and maybe the way it provides it is not Linux friendly. So we just don't have anything to do. But we still would like to explore this conceptually. So that's why I think there's 10% to be explored
Mm-hmm.
there. And that's it. Man, I wish I had a glass of water.
Yeah, you need it really. Really, that was a very good explanation. Really, it cleared a lot of stuff in my mind. Because also these names, man, I don't know where they get these names from.
We have a box of terrible names. We choose the worst, and that's the next project name.
Yeah, like in web development, names make sense. Here, it's all like,
Yeah.
what are those
Well,
names?
I think RAUC is an acronym and it means something good, like
Yeah.
reliable, automatic update, something client. I don't know. I forgot. LVFS is like Linux vendor firmware service. I don't know what Yocto or means. Bitbake means nothing. It bakes bits. There's like if I can be grumpy, there's a binary called wick. There's like a
Mm-hmm.
script called wick, and it's a wordplay. It's something I actually don't understand, a reference to something older, which was also a wordplay on something. And this Wick thing builds images. It's like a tool to build images. Like,
Oh.
what? Why is it called Wick? Because, yeah. So yeah.
So yeah,
Um, so Hogbit, like, why? It's a nice word, but I just don't get why it's called Hogbit. It's fine. But it is what it is.
yeah, yeah. Yeah, sooner or later, I'll get familiar with all these names. So.
Yeah, one of the things I think we could do is just have a glossary. I'm really serious. Like a have a wiki page that's just our
Mm-hmm.
glossary, and we just expand it as we have terms that we understand, but maybe they're not like household names or actually words that mean stuff. They're just identifiers for things. So yeah,
Yeah,
I
that'd be
think we could
great.
do that. So yeah,
Mm-hmm.
I mean, one general word of advice: just be proactive. Don't be afraid to do things. Just do like, in my opinion, it's
Mm-hmm.
better, way, way, way better to ask for forgiveness than to ask for permission because it means you can feel free and unlocks your creativity and just having drive, passion, desire to do stuff but not be afraid. Oh, do I need to ask a permission, file a ticket? No, just forget all of that. In my opinion, the beauty of open source is people get to do their best work because
Mm-hmm.
they actually want to do it, and they have a way of doing it that is just so unique and so different from working in a like a top-down, lockdown management strategy environment that just kills all this creativity. So just feel free to
Mm-hmm.
explore, feel free to try things out, and yeah, just feel done. And maybe one more thing: don't be afraid to ask. Just keep like I'm honestly ignorant about so many of these things at the level that I would be ashamed to admit if it wasn't just a normal case. Like people are just ignorant about the most part of the stack because they look at a small part, or they have looked at the broad selection but very shallowly. So it's normal. We just don't know everything. We know everything as a group. We don't know everything as individuals. So just go ahead, ask. It's fine to ask, and most people will not know either. So be persistent, keep asking, keep looking, keep exploring. um,
Perfect.
and yeah, I think that's it. And be friendly. Lots of people from other companies, from other, like, not even companies, like they run their own companies. They're just running a project.
Mm-hmm.
Yeah, be friendly to them. Be honest. Be ask, listen, and tell what you want to do, and just do what you want to do. Sometimes we agree. Sometimes there's a common vision. Sometimes people just drift apart, do different things. It's fine. One thing I found by working in open source for a while is that you tend to change your email address, but you tend to work with the same people for a very long while. So it's good to be
Oh, that's
friends.
nice.
It's really good
Yeah,
to be
yeah.
friends.
Yeah, like I've seen yesterday that everyone has like 15 plus years of experience like within the team. It's crazy.
That's a very good way to say we're old.
But super welcoming.
Yeah,
Super friendly.
yeah, yeah. I remember when I started my first open source piece, and it was just so everything was so weird, different, and unknown, and it was just it's a fun ride. I think you will enjoy it.
No, no, I'm enjoying it already, but it's just a bit overwhelming. But it's just the first period. It's fine.
Mhm. All right,
Perfect.
cool. So let's wrap this up.
Mm-hmm.
I'm gonna publish this video somewhere if you don't mind.
Yes, please.
And yeah, I'll get back to you. But
Thank you.
all right, cool. See
Thank
you
you
around.
so
See you back
much.
on IRC. See you back on Mattermost. I'm hitting
See you.
stop recording now.